Hello everyone, my name is Modebola Olowu and I'll be presenting on the Internet of Things, demystifying smart cities and communities. Our overview for today, we're looking at what IoT is all about, concept and services that inspired smart city, the service architecture being employed, the application of IoT in the smart city of Cordova, looking at future trends, we conclude and I'll take questions from there. Now, what is IoT? This is a topic that is becoming really interesting and popular over the years. It's a matter of now, it's a matter of the future. And really, the Internet of Things just pushes towards the use of smart devices being connected over the internet network. And yes, you make things happen. We're saying anything that can be connected will be connected. So we're talking of your smartphones, with your cars, with your wearables. We're talking of your smartwatches, your glasses, your fridge at home, your TVs at home. We're talking of having everything that can be connected to carry out different types of tasks connected with each other. So we're saying the Internet of Things is about empowering your devices and objects so they can see, hear, and smell the world for themselves. So they're not just being smart, but they can actually carry out tasks based on the things they've seen, based on the things they've heard, and based on the things they've perceived. So they can make decisions, they can make smart decisions on your behalf as the owner. There's been cases where a fridge can actually help you to make orders from Walmart based on the fact that maybe your milk has finished or you've run out of water, you run out of soda water, or run out of drinks in the fridge. So the fridge can sense or can deduce that there's no more drinks in the fridge, and then it can make orders for you from Walmart. Now, what are the concepts and services that are driven towards the smart city in itself? So we are talking about smart health, we're talking about a more structural way of managing the waste in a city or in a municipal. Now, all of these concepts driving towards smart parking, smart lighting, avoiding traffic congestion like the ones we have in Lagos. When you have a smart city and you make use of the Internet of Things, you can actually have less congestion. You have it in a more orderly way, where you have your transportation system in a more guided situation. So the benefits of having this concept drive towards smart city, you can see lower consumption of energy, you can have the reduction of air pollution. So air quality is guaranteed, air quality is better. The citizens are almost seamlessly feel really safe because the environment is more conducive. The living quality is better. It improves really the standard of living. So when you're talking about Internet of Things in relation with the environment of the places you stay, it's more about improving your standard of living. That is actually what has driven towards the concept of the smart cities. Now, what service architecture has been involved in the building of the city? So the IoT architectural model involves 4-layer models, and we're talking about the application layer, which in this case, I'll give an example of the environment in which you live in, or the environment in which you want to turn to the smart city or a smart home. And then we have the supporting layer, which looks into data fusion inside, okay, software implication, what coding have you implemented, the database management, and then we'll come down to the network layer, which is the house of the networking itself. So we're talking about the internet in which the smart devices will be connected over time, and then the perception layer, which looks into the smartness of the device, how sensitive is the device. So we're looking at different sensor gateways, the various sensors and actuators that are being used for the IoT models in this case. And when we talk about IoT for smart cities, in relation to the service architecture, we're actually looking at having an IoT service host and an IoT service provider. So we're looking at what device can be used to carry out this task and what kind of service platform do we need it to run on, and then we need the network operator in itself, which is acting like the middleman to make sure we are meeting from the left to the right and we're actualizing what we want. Now, the web service approach is what is being implemented for the IoT service architecture, and then we have two protocols that are being considered. We have the unconstrained protocol and we have the constrained protocol. So we're looking at the apparatus markup language against the Excite when we're talking about the data. We're talking about the transfer TCP protocol, the user datagram protocol. We're talking about the application of transport layer. When it comes to the network, we're looking at the internet protocol. We're doing version 4 or version 6 when it comes to the constraint. We're doing version 6 when it comes to the constraint. So when it comes to building stack for the IoT nodes, we can actually make use of any of these two protocols for the smart cities. And then we can also see an abstract representation of the web service approach for an urban IoT-based network. Now, for the purpose of the smart city paperwork, we decided to look into the constraint application protocol. And like I said, we have 4 abstract layer structures which we've considered. So in this particular diagram, we're looking at it being broken down into what we wanted to use. So we're looking at the application layer, which I explained it earlier as the smart home in itself, the point in which you want to establish what you want to make use of. So then we're looking at the request or the response, and this can actually come in the form of a message from the user datagram protocol. So the message layer also happens to be in the lower layer, has been designed to deal with the user datagram protocol and asynchronous switching, which was and then the communication method utilizes the request or response layer and deals with the response that comes through the message. These are the protocol stacks for the web service-based IoT nodes, and I'll be picking them one after the other. The other time I compared both the unconstrained and the constrained, and I was making references to both how they apply to data, application, and then the network. So the first one we're looking at is the data layer, and you can see that from the unconstrained perspective, XML is commonly used, and the size of the XML is often too large for the Internet of Things. As such, schemaless and schema-informed kind of encoding are being used. Now, when it comes to the application transport layer, that's the application transport layer, we are looking at the constrained application protocol being supported by the internet host using cross-proxy, of course, and then you see how the user diagram protocol is being transferred based on binary formats with the use of retransmission strictly. When it comes down to the network layer, we're talking about the Internet Protocol version 4 being used to address issues or problems that arises from the network. And we're also looking at the address spacing, which usually is around the 128 bits per address field. Now, the link layer technology. The reason why we've employed the constrained application protocol is pretty much because it's relatively low, so costs, and when it comes to maintenance, it's actually most preferred. So, but when you're looking at the unconstrained kind of protocol to build or to implement a smart city, yeah, fine, it's highly reliable, low latency, high transfer rates, complex and high